Okay, so we did writing chemical equations last class. So today it's balancing chemical equations. Now, what the reason that we have to do this is because when you write your chemical equations, you're just writing the chemical formulas of the reactants and products on each side of the arrow. So it's kind of like if I told you, like, oh, if I wanted to make a cake, well, I need flour and I need butter and I need sugar and I need maybe some like milk or oil. I probably need some baking soda or baking powder. If I want to make a chocolate cake, maybe I need cocoa powder. All the egg. I probably need eggs. Eggs are in cake. So I'm listing all the ingredients, but like, do you know how to make that cake just from what I told you? If I just tell you need to put all that stuff together, are you going to make a cake?
Not a
No.
good one.
What else? What other information do you need before you can make that cake?
How much time? How to bake it?
Yeah. So the temperature or the time to bake it. What
Like the
else?
mix.
The amount of, like what amount of like flour and things I need.
Exactly. So I told you you need like flour and butter and eggs and sugar and cocoa powder, but I didn't tell you how much. So it's like, do you need 5 cups of flour? Do you need like a tablespoon of baking soda? How much do you need? And so that's really what the difference between last class and today is. Last class, we were focused on what ingredients do we need and what products will we make. So, here's all my ingredients and I'm going to make a cake. Okay. Those are like my reactants and products. So we started out with like whatever elements and compounds were on the reactant side. And then we said, they're going to make this. Okay. They're going to make these products. Now today we're concerned with the amounts. Okay. And so really that's what today is all about. And so it's called balancing because when you have a correctly written chemical equation that is balanced, you should have the same number of atoms of each element on both sides of the arrow. And what that goes back to is if you look at your lesson, how it was started today, this is called the law of conservation of matter. Sometimes it's also called the law of conservation of mass. And then you also learn that there's the law of conservation of energy later on. And so basically what this states is it tells us that matter or mass cannot be created or destroyed. Okay, so if I start with 10 grams of this and I add it to 15 grams of this other thing and I react them together, 10 plus 15 is 25. So that means on the product side, I still have to have 25 grams of mass. Okay, now it might be in different places. Maybe instead of 10 and 15 for the reactants, maybe now I have 20. One thing is 20 grams and the other thing's 5. But the total should be the same. Okay, and that's what this law is telling us. And so because of this law, when we write chemical equations, we have to balance them by using what we call coefficients. And that's what we're going to see as we go through. And so there's a little video here that you can watch that really it's really good because it has visuals of some different atoms and then they kind of form molecules and it shows you like if these are the reactants, then all of the atoms, all they're going to do is their bonds are going to break and they're going to rearrange and they're going to form new elements and compounds on the product side. So when we do chemical reactions, it's not like magic. It's not like we created something out of thin air. We just took what the amounts of the elements and the compounds that we had and we transformed them. We used some energy, we broke their bonds, we let their bonds reform, and they made different elements and compounds on the product side. But when I look at, how many atoms of every element are on both sides, those numbers should be the same if it's balanced. If they're not the same, then it means it's unbalanced, and that means that you need to do something to balance it. Okay. So let me go to page 2 here. All right, so how do we balance them? We add these numbers in front of our chemical formulas. These are called coefficients. So when we write chemical formulas, like this is H2O, this is water, we have these little numbers. Remember, those are called subscripts. So we need to know the difference between these two numbers because subscripts, the little numbers, the one that's here in pink, those are part of the chemical formula. So if I'm told to write the formula for water, water's H2O. Once I write that, I cannot change that to subscript. Okay, because if I change that to subscript, it's not water anymore. It's now going to be a different chemical. So once if you're given the name of an element or a compound, once you write its formula correctly and you put it in your chemical equation, you cannot change that formula. You cannot change the subscripts. Okay, that's like breaking the chemistry law. That's like a no-no. Okay, what you can do is you can add these large numbers in front of your chemical formulas. And this is just like math class. If I put a number in front of something in math class, what does that usually mean I'm going to do? What do you guys think?
Multiply.
Yeah, usually that means I'm going to multiply. And so that's kind of that same concept we're using here. So if I put a big 2 in front of here, that 2 is going to multiply by every element that is in the chemical formula that I put it in front of. And so when you have a coefficient and a subscript, like on the hydrogen here, then this 2 coefficient multiplies by the 2 subscript. So in this, the way this is written with this 2 coefficient added in front, this means that there are 4 hydrogen atoms the way that I've written this, okay? Because 2 times 2 is 4. For the oxygens, though, there's no subscript. So what happens if there's no subscript? What number should we like pretend is there? Like on oxygen right here.
1.
Yeah, if there's no subscript, remember it's an imaginary 1. Okay, so remember that if there's nothing there, it's a 1. It's not a 0. Okay, because if I multiply something by 0, that gives me 0, and that doesn't make sense. Okay. So if there's no subscript, it's an imaginary 1. So that means I would be multiplying the 2 coefficient by the imaginary 1 on oxygen. And so that means there are 2 oxygen atoms the way that this formula is written with this coefficient in front of it. And so as it says right here, and I'm going to like repeat this until you guys, are tired of hearing me say it, but we use the coefficients to balance. You never change subscripts. You cannot add subscript. Like I can't just put another 2 behind the oxygen if I need to balance. Like I can't do that. That's not water anymore. H2O is water. H2O2, that's hydrogen peroxide, which is what you get in those brown bottles at the drugstore to like bleach your hair or to bubble up and like disinfect wounds and things like that. You definitely don't want to confuse those because drinking hydrogen peroxide can kill you. Drinking water will not. Okay. And so this really here just goes over kind of what I just said, okay, that goes over the difference between the subscript and the coefficient. And here it goes through that example I just showed you for hydrogen. So I'm multiplying the coefficient by the subscript for each element in order to figure out how many atoms of that element do I have. So on the second example, and you guys might have already seen it, but I'm not gonna scroll down. So on this one, I have 2 elements. I have aluminum and I have oxygen. So the way that this is written with the current coefficient in front of it, how many atoms of aluminum are in that example? If somebody wants to. So let me check the chat. Somebody said something in the chat. Yes, Mariah, breaking the law. I just saw what you said earlier. Yes, it's breaking the chemistry law. I will fine you. Okay, I'll give you a ticket. Anybody want to tell me about aluminum? So I have a 2 coefficient and then a 2 subscript, I misspoke, and a 3 coefficient. So how many aluminum atoms are in this formula right now?
You'll have 6.
You have 6 because 3 times 2 is 6. What about oxygens? How many oxygen atoms are here?
9.
There are 9, okay? Because again, I'm multiplying the subscript that's part of the chemical formula. I'm multiplying it by whatever coefficient I have added in front, okay? There is one more on here. This one's a little tricky because this one has a polyatomic ion that is in parentheses and has another subscript behind it. So be careful when you have, if you have ionic compounds with polyatomic ions in parentheses like this, because they're a little trickier to do. But you're still just following your basic math rules. Okay, so let's go through and let's do them in order. So Cu is copper. So based on how this is written, how many copper atoms are in this formula?
3.
There's 3, because right behind copper, there is no subscript. So that's an imaginary 1, and it just multiplies by the 3 here. Now, the nitrogen and the oxygen that are in this polyatomic ion, they're a little trickier. So you have to look what's right behind the element. So for nitrogen, there's an imaginary 1 right here, but then it's in parentheses and there's another 2 subscript outside. So if you have something in parentheses, look right behind the element for a subscript, then look outside the parentheses for that subscript, and then you also have to consider the coefficient. So for nitrogen, there's an imaginary 1, and then it would get multiplied by this 2 subscript that's outside the parentheses, and then it gets multiplied by the coefficient. So total, if I do 1 times 2 times 3, that gives me 6 nitrogens in that compound. Now, keeping that in mind, can anybody tell me how many oxygens are in this compound? Yes, there should be 18. So right behind the oxygen is a 3. And then I would multiply it by the 2 that's outside the parentheses. So 3 times 2 is 6. And then that 6 then gets multiplied by whatever coefficients here, which is a 3. And 6 times 3 would be 18. And so you can kind of scroll down and you'll see here. What it says here is it's just telling you that the subscript, the little number 2 out here, it applies to anything inside the parentheses. So if you have something in parentheses and another subscript outside of it, that subscript, it's like it distributes, it multiplies to any elements that are inside the parentheses. So just be careful on ones like that, because you do have to, it's a little bit more math, because you have to kind of consider the subscript right behind the element that's in parentheses, the subscript outside the parentheses for them, and then also the coefficient, okay? But it only applies to the things in parentheses. It does not apply to the copper, okay? Because the copper is not in the parentheses, all right? All right, so keeping in mind, okay, so now the actual process of balancing, okay, we talked about you have to have the same number of atoms on both sides, and a balanced equation obeys that law of conservation of mass we talked about. And so, for example, here's what we kind of did last class. We just wrote out the equations with the chemical formulas. We didn't worry about the numbers. We didn't worry about the amounts, okay? But if I look at this, this is unbalanced, because if we use what we just did on the counting atoms, I can see there are 2 hydrogen atoms right here, and there are 2 chlorine atoms right here. That's the reactant side. Here's my arrow. On the product side, though, neither of these have coefficients. I only have 1 hydrogen and I have 1 chlorine. And the reason for that is because naturally, hydrogen and chlorine are both on that list of diatomic elements that we had in our notes from last class. So if hydrogen is by itself and chlorine is by itself, they have to have these 2 subscripts. Okay, just like oxygen is always O2 when it's by itself. But when they go into a compound, and in this case, it's making hydrochloric acid, okay? When they go into a compound like this with an acid, we have to look at their charges to balance and write the formula. So hydrogen is always +1 because it's in group 1. Chlorine's in group 17, so it's always -1. And so their charges cancel out, and I don't need subscripts to write the formula for that compound. So then if I want to balance it, this is where I determine, well, I need to add in a coefficient, okay? So what you do, and we're going to look at this when we get to the practice in a second, is you off to the side or underneath your reaction on some scratch paper, wherever, make a list of your elements and then list out the number on each side, okay? And then you've determined where you put a coefficient, where can you put a number that will multiply. So on this one, I have 2 hydrogens here, 2 hydrogens here, but on this, I'm sorry, 2 chlorines here. And then this side, I have 1 hydrogen and 1 chlorine. So what's going to happen is the product side where this HCl is, both of them need to be doubled. We need to multiply the hydrogen by 2 and the chlorine by 2. But I can't add any subscripts in. I can only add coefficients. So what I'm going to do is I'm going to put a 2 coefficient in front of that entire formula. And just like we saw on the counting atoms, that 2 will multiply by the hydrogen and it will multiply by the chlorine. And by just putting that 1 coefficient in, I have now balanced my equation. If I were to count up all my atoms, I have 2 hydrogen atoms on the reactant side because of the subscript in this formula. I now have 2 hydrogens over here because I added that coefficient that's going to multiply by the hydrogen. I have 2 chlorines here because of chlorine being a diatomic element with the subscript. And then again, because I added this 2 coefficient, it will also multiply by the chlorine here, which will make it be 2 as well, okay? And again, here, never, never, never change the subscripts, only add and change coefficients, okay? So at the very end, and I'm not gonna show it right now because it's a whole video, but if you are still having trouble, even after we look at examples, you need to watch this video, okay? He goes through multiple examples, just like that one we just looked at, and he even shows you the little pictures of what the molecules and the atoms and the compounds would look like, okay? So highly, highly recommend, if you have not watched this video, go watch it because it will help you. He goes through the process of creating the little chart that I was talking about with, so you can keep track of your numbers. And it's the same way that your self-check practice is set up, okay? So we're gonna go and look at that really quick. So the self-check practice, the way it's set up is it's a Google sheet. And when you click on it, it's gonna tell you to make a copy. And then you can practice. There are 10 equations that they're already written out with the formulas. You are only having to do the balancing part. You're not having to write out the formulas from the names. You're just practicing what we just talked about with balancing and adding coefficients. So I'm going to open it up here and we're going to take a look. And it's set up to where when you get it right, everything's going to turn green and it's going to tell you that it's balanced. Okay. So when they start out, they're all unbalanced. And so if it's green, that means it's balanced. If it's red, that means it's unbalanced. And so it says up here in the directions, it says balance each of the chemical equations below by adding or changing the coefficient of each chemical equation. And those are the blue boxes. So wherever the blue boxes are, that's where you can type a coefficient. So looking at, this is the list I was telling you about, this little table. So they've listed the only elements in this reaction. There's hydrogen and there's oxygen. So they've made a list for the reactant side and they've made a list for the product side, and they've counted. Over here, there are 2 hydrogen atoms because of the subscript, because hydrogen's diatomic. There are also 2 oxygen atoms because it's diatomic and it has that subscript. On the product side, the formula is H2O for water. So hydrogen has a subscript, so it's 2 atoms here. So you can see it's green because they're the same. They're balanced already. But the O, there's no subscript. So there's only 1 oxygen atom here. So that's why it's red, because oxygen is not balanced right now. Okay. So what we need to figure out is like, which blue boxes do we need to type coefficients in and what number do we need to put in? So what you want to do is your numbers always have to go up. You can't, like, I cannot make this oxygen over here on the reactant side that's 2. I can't decrease that because I can't change that subscript. So always look for the side that's lower because we're going to be multiplying. We're always going to be making the numbers go up and match the larger number. So what you probably want to start off looking at is this oxygen over here is 1. And what can I multiply 1 by to make it 2?
2.
2. So wherever oxygen is, which it's the only compound over here, so oxygen's in this formula. So I'm going to click on the blue box in front of water and I'm going to type a 2 coefficient in. If it goes, there it goes. And then give it a second because it's going to have to load because I'm on the call, so it's going to be a little slow. But what's going to happen is we're going to see, eventually we watch the oxygen on the count boxes because they're going to change as soon as it finishes updating itself. So you should not have this lag. I have this lag because we're on this call and I'm trying to do this at the same time. So yours should update pretty much automatically. All right, come on. It's working, it's trying to do it. So by putting this 2 in front, we're multiplying the oxygen. So this oxygen is going to change and become a 2. But remember, the coefficients affect everything in the compound. So putting this 2 here also affects the hydrogen. So what do you guys think the hydrogen is going to change to here on the product side? Yeah, oh, there it goes. Okay, so now we fixed the oxygen. So now see the oxygens are green, they're both 2. But now the hydrogen went red because now the hydrogen's not balanced. So this side has now got 4 because this multiplied. The coefficient we added multiplied by the subscript that the hydrogen already had. And so now we got to go over to this side. We got to fix the hydrogen over here because remember, you can only increase the numbers because you're multiplying. I can't decrease. So now over here, there's 2 hydrogens here because the subscript, but I need 4. So what can I multiply this by to get 4 hydrogens?
2.
Yep. So I'm going to click here. I'm going to type another 2 coefficient in front of hydrogen. And then if we give it a few seconds, there it goes. So look, everything's green. And then over here, it changed to balanced. That's how I know I'm done. So in this equation, my coefficients are 2, imaginary 1, and 2. So if there is no coefficient, like we didn't add anything in front of the oxygen, it's an imaginary 1. Just like in the formulas, if there's no subscript, it's an imaginary 1. Okay, so we just leave this one blank, and it's understood that there's a 1 there because we have the oxygen formula. I know there's 1 molecule of oxygen because it's written here as O2. I don't need to write the 1. And so that's what you're doing on all of these. So if I go to the next one, you know, and then they're going to get a little more challenging as you go. So let's go down here and do, I'm trying to find one. Okay, let's look at number 8. So number 8, okay, number 8 has a polyatomic ion. See the OH right here in parentheses? It's not in parentheses here because we didn't need another subscript. So when you are balancing, if you have a formula that has a polyatomic ion, like OH, like hydroxide, if that polyatomic ion stays together on the other side of the equation, you can consider it like one thing. So you do not have to split this into oxygen and hydrogen. If you want to, you can, but I will tell you, as long as the OH stays together, like it was OH here, and it's still OH over here, then leaving them together makes it a little easier, okay? Now, what you can't do that if they split apart. So like if I had OH here, but then maybe the oxygen was in one compound and the hydrogen was in a different compound, then you do have to do the elements separately. But if you have a polyatomic ion that does not split apart, it stays together, and I can see it's still together over here, then when you do your list, then just list the polyatomic ion together, okay? So on this one, I have iron 3 chloride, so FeCl3, and I'm reacting it with sodium hydroxide, NaOH. And then my products, I produce sodium chloride, NaCl, and I produce iron 3 hydroxide, Fe, and then OH3. So for my initial count, okay, I have 1 iron here because there's no subscript. There are 3 chlorines because it has a 3 subscript. There is 1 sodium because there's no subscript. And then since I'm considering the hydroxide as like 1 unit, I'm not separating oxygen and hydrogen, I listed OH, and there's just 1 of it because it's not in parentheses. It doesn't have any subscripts or anything extra. Now, when I go to the product side, iron, it's now over here in this compound. It's still 1 because it does not have a subscript right behind it. Chlorine is 1. There's no subscript here. Sodium is 1 because there's no subscript. But now hydroxide's 3 because the OH is in parentheses and there is a 3 outside. So I now have 3 of that hydroxide ion. So right now, as it stands, the iron and the sodium are balanced. The chlorine and the hydroxide are not. So we want to pick either chlorine or hydroxide, whichever one, and then figure out which side we need to adjust. So I usually go in order of how they're on here. The only thing I will say is that if you have equations like this one on number 9, so you see how oxygen is in 2 different spots here on the product side, but over here it was only in 1 spot. On problems like this, if you have one element in multiple spots, save that one for last, okay? And a lot of times it'll be oxygen. So if you have reactions like this where oxygen's in multiple spots, wait to do oxygen last because it'll be complicated if you don't wait to do it. If you wait, it's going to be easier to do in the end, okay? All right, so going back up to this one, if we do chlorine, which side do we need to add a coefficient for chlorine? The reactant or the product side? What do you guys think? So the reactant side, I have 3. The product side, I have 1. So which side needs to increase?
Product.
Yeah, I need to increase the product because remember, I cannot decrease numbers. So I can't make this 3 go lower. I have to multiply the 1 by something and increase it. So what number would I multiply this by in order to get it to match the amount that I have over here?
3.
Yeah, I'm gonna have to multiply chlorine by 3 because 1 times 3 would be 3. So what I want to do is I want to find chlorine. Chlorine is here. It's in this compound. So here it is. I have to put the 3 in front of the whole compound. The other thing, and this is maybe not going to be as much of an issue since we're online, but when you write problems out like this, sometimes I see people that they'll try to put a 3 in between the Na and Cl here. Like they try to put Na and then they put like a 3 coefficient before the Cl. You cannot do that. NaCl is a compound formula. You can't put anything in it, okay, once it's written. So the 3 has to go in front here. And so that multiplied by the Cl. So now the Cl turned green, but it also multiplied by the Na. So now the Na does not match. Okay. So Fe and Cl are good, but Na and OH do not match. The product side, there are 3 sodiums and there are 3 hydroxides. The reactant side, though, there's only 1 of each. So then what do you guys think that we need to multiply by? Yeah, so Mariah says 3 on the reactant side. That is correct. So I'm going to find sodium. And actually, if you pay attention, when you do this long enough, like I can tell sodium and hydroxide, they're here in the same compound. So if I put a 3 here to fix the sodium, that's also going to fix the hydroxide. So watch and it'll change in just a second. There it goes. So it fixed both of them because they were in the same compound. All right. And so all of this is kind of like a puzzle. And so you have to kind of look at your formulas, count up the number of atoms on each side, and then you have to see, okay, what it already matches and what do I need to go change? What can I multiply by to make them match? Okay. And then if it affects another element, like when we put the 3 here to fix the chlorine, it also changed the sodium. You have to keep track of that because at the end, you want everything to be the same. Okay. So here we have 1 iron, 3 chlorines, 3 sodiums, and 3 hydroxides. So everything is balanced. So on this one, my coefficients are imaginary 1, 3, 3, imaginary 1. Okay. And so that's really what you're doing on this is you are looking at the count. You're seeing where you need to start putting in coefficients to multiply. And then as you type something in, it will update and it will tell you what changed. And then you can use that to adjust as you need to until you get to the point where you've put coefficients in where they need to go and everything should be green and it should say balanced here. Okay. And so you have a few more. So we did kind of 2 together. There's 8 more on here that you can use to kind of check yourself and practice with it before you go on to your last thing that you have for today in Canvas. Let me go back to Canvas. So after you've done that, so this is not for grade, but you know, you're about to have a quiz on the next one. And there are some that are going to ask you to do that on the quiz. So when you go to the little checkpoint quiz, this is going to be covering stuff we talked about on Wednesday and today. So it's got, you know, you have to be able to recognize reactants, products, what are the formulas? So what would the equation look like? And how do you balance it? And so there are videos, okay? One of our other chemistry teachers, Mr. Villarreal, he took the time to make these really nice videos that show you guys, because obviously we're not here in person. And so if we were here in person, we would be doing labs. Like you guys would be using these chemicals, you would be reacting them, you would be making observations, and you'd be describing them to me and all that kind of stuff. But since we're not able to do that, Mr. Villarreal actually recorded some reactions and he made some really nice videos where he did like voiceovers and he described them to you guys and showed you what they look like and the labels for what the elements and the compounds are. And so what you'll do for each question, you will watch this video. When you're done watching it, you'll answer the questions over here on the side that go with it, okay? So the first one has 5, the other ones have 4, okay? Or actually y'all's are probably gonna be mixed up, but so 2 of them have 4 questions, 1 of them has 5. And so it starts out with things like, you know, what are the reactants and what are the products? And then here is like, what would the reaction equation be? And so that goes back to what we did Wednesday with writing the equations. And then you will, the last one is going to ask you to type the balanced out. So what you can do is you can copy, it tells you the directions to copy the reaction from the previous question. And then you can use that and just type in your coefficients like we did on the practice. Okay. All right, so let me stop sharing. before I let you guys go, the last thing that I wanted to take a few minutes to talk about today was at the end of class last time, there were some people that were asking about like classes for next year. And I sort of talked about it a little bit, but I told you guys I would try to kind of get some more information to show you guys today. And so that is what I'm gonna do right now. I'm gonna switch over and show you guys some information. So you have a lot of different options. There are several advanced science options that I sort of showed people at the end of class last time a little bit. And then if you don't necessarily want to do an AP or an IB science class, there are some regular science classes, but again, there are a lot of different options. Okay, so this is